So to increase the metal removal rate, etchant is agitated and it is heated. Strength of the etchant maintained by proper filtration, because whatever this chemically this material after during machining it dissolves into the etchant. So this is the difference between chemical machining and electrochemical machining. In electrochemical machining, whatever these chemical reaction products are there, it does not dissolve into the metallic hydroxide, does not dissolve into the electrolyte. But in case of chemical machining process, whatever these reaction products are there, it dissolves into the etchant. That's why this etchant should be filtered properly before recirculation. Addition of new chemicals or replacing certain percentage of used etchant by fresh one. So to avoid uneven metal removal rate, fresh etchant is continuously sprayed on the component, or this component is submerged into the etchant tank. So metal removal rates, either it occurs in the downward direction or it occurs in the laterally. So you can see this is the metal removal rate in downward direction. So this is, you will get the depth of cut, and when, so this is the maskant layer here. So this portion actually it was open, and this portion and this maskant layer is there, but there is a lateral machining is there. So this, because of this lateral machining, undercut occurs. So extent of undercuts, so this is actually unwanted. This much of material actually it is unwantedly it is removed from the workpiece. So it is not wanted. So this lateral machining is done due to the undercut. So extent of undercut depends upon the depth of cut, type and strength of etchant and the workpiece material. For certain workpiece material, this undercut is more, and if you increase the depth of cut, obviously your undercut will be more. And type of strength, this undercut also depends on the type and strength of the etchant also. So how to quantify this undercut? Undercut is quantified by H factor, which is U. This H factor is defined by undercut by depth of cut. So this H factor is defined by undercut U by D. D is the depth of cut. So machine depth and extent of undercut control, it is can be controlled by the time of the workpiece it is immersed into the etchant tank. So to avoid non-uniform machining, gas bubble should not be allowed to get trapped into the under the maskant. So this whatever during chemical machining, whatever these reaction products are generated at that time, because of this chemical machining, chemical reaction, gas bubbles also generated. So if these gas bubbles are actually trapped inside the maskant material, maskant and workpiece, then there will be less or inaccurate machining will be there. So whatever these bubbles or gas are generated, it must not be trapped inside the workpiece material. So after etching, parts is cleaned. For bigger material, for thicker or more durable mask, it is mechanically cleaned, or for chemically, or sometimes it is chemically cleaned. For thinner mask and sophisticated parts, it is chemically cleaned. So what are the different process parameters for chemical machining process? Type of etchant, temperature of the etchant, type of maskant, method of applying the maskant, and method of circulating the etchant on the workpiece surface. So surface finish generally obtained is 0.75 to 3.75 micron in case of chemical machining process. So there are different methods for depositing the maskant onto the workpiece surface. So already we discussed, there is one method, first method is the cut and peel method. second one is the screen method, and third one is the photoresist method. So this first we shall discuss the cut and peel method. So in cut and peel method, these are the materials, neoprene, butyl and vinyl based materials are used as a maskant. Dipping, spraying or flow coating can be used. So you may be dip the workpiece inside these kind of materials, or it may be this maskant, these materials, these chemicals may be sprayed, these maskant materials may be sprayed or flow coated on the workpiece surface. So this coating thickness is 25 micron to 130 micron. So this coating is made on the entire surface of the workpiece because it is dipped into the coating tank or maskant coating tank. So this entire workpiece actually coated. After that, this maskant is cut and peel off from the area to be exposed for the etchant for machining. So then scribing and peeling of the maskant is done by hand using a template. So accuracy obtained by this cut peel method is 130 micron to 750 micron depending upon the size and type of the component being produced. So machining depth depends upon the etching time. Usually tapered workpiece is obtained. So this is the good method for stepped component using a rescribing technique, and good for a large size products also, this cut and peel method used in chemical, aircraft and missile industries. So this is used for, it is good for the batch production and products with a large depth, generally more than 1.5 millimeter. If the depth of machine surface is more than 1.5 millimeter, then this kind of cut and peel method is used. It is good for the batch size production. So this is the workpiece here, maskant coated already. So if you see the cross section of this maskant, if you take a cross section here along this line, you can see. So this is the workpiece material, here this maskant layer, and this is the exposed area where we need the machining to be carried out. So these are the exposed area, and this is the photoresistant, these are the maskant here. So it is deposited on the workpiece surface. So here this maskant is peeled off from the marked area for etchant reaction. So this is the schematic diagram of the cut and peel method. So again, so this part to be milled. So this is the workpiece. After that, it is, this part is actually, it is coated with the maskant after dipping into the maskant coating material, and then this portion actually cut and peeled up. This portion of the workpiece is cut and peeled up for the machining to take place in this zone. So after machining, you can see this is the part is generated, and this portion there is a overcut is there. Here you can see this is the overcut or undercut into the workpiece surface. After that, second option is the screen printing method. In screen printing method, it is used for mass production where less accuracy is obtained. Here one screen is used. It is maybe made of stainless steel. Stainless steel is one of the screen is used. This stainless steel screen is kept on the workpiece surface. After that, this maskant coating actually poured into the over the screen, and in the screen actually where it is the screen is the impression of the workpiece to be machined on the workpiece surface. So where these some blank portions are there on that screen, their maskant is actually filled up, and then after that it is baked, and rest of the portion where these maskants are not there, their machining will be carried out. So it is good for high volume production it gives low accuracy, low etching depth, less than 1.5 millimeter, and part size actually generally less than 1.2 to 1.2 meter. So within this range, the workpiece size is there. So usually stainless steel screen is used. Screen blocks of the area to be etched. Press the screen against the surface of the part and roll up the maskent. And this maskent actually it is filled up where in the screen where some gaps are there, and rest of the portion will be opened for machining. So remove the screen, after that remove the screen and dry the part by baking operation. So third method for generating maskant layer is the photoresist method. So generally people call it photochemical machining. So it is used for complicated parts. For complicated parts, this is very useful method for generating very accurate shapes. This is very useful method. So these are the different steps of photochemical machining or photoresist method of making maskant layer on the workpiece surface. So initially this very enlarged view of the part is actually generated. After considering the undercut, generally one artist actually make the enlarged view of the part. So this, after that, the photograph and the artwork, whatever this artwork is produced, it is reduced to the original size, which is highly accurate photographic master transparency. Highly accurate photographic master transparency is generated. Or you can make the master transparency, master film by laser pattern generator. It receives the nowadays computers are used, a CAD model is used. It takes the CAD model into the system and produces the features directly onto the photo master film. In earlier days, one artist actually generally make this bigger size, then it is actually reduced and then it is made on a photoresist or photo master film. So this part is chemically cleaned, and to remove the whatever these darts and oxide layers are there on the workpiece surface, it is chemically cleaned. So after that, a thin coating of photoresist. This photoresist actually light activated etchant resistant material. So a thin coating of this photoresist actually is deposited on the part on the workpiece, and then it is dried by baking. After that, this photoresist photomaster film and workpiece, it is made together, it is kept together in intimate contact, and very strong ultraviolet ray is thrown through the photomaster on the workpiece, and after development this coating is actually removed from all the areas where etching is to take place. So now part is now chemically etched and residual photoresist is stripped off after that, and by this process, photochemical machining process, 0.025 millimeter accuracy can be achieved and repeatability is 0.0005 millimeter. So this is the different method, different steps of photochemical machining. First you have to clean the workpiece, dip or spray the workpiece to apply the photoresist coating. Photoresist coating is deposited. So these negatives are applied to the surface. Apply master pattern here, over there, both sides of the photoresist. So this is the master pattern. Here this is the master pattern, and this is the photoresist material here. And after that, ultraviolet ray, it is exposed to the ultraviolet ray. So after exposing this workpiece under ultraviolet ray, this photoresist developed over there, and unexposed areas of the resist are removed. So these unexposed areas are actually removed. So after that, this workpiece, now it is machined by chemical etchant and after that this whatever this mask is there, this mask is actually removed. So this kind of complicated surfaces can be generated by using the photochemical method. This can complicated details. So these kind of complicated details can be generated by photochemical machining process. So there are different choices of maskings are there. So these choices are, it should be resistant to the etchant. This masking should be resistant to the etchant, should be easily removable after etching, should not have any chemical effect on the workpiece, and should be stable at high temperature of etchant bath. Etchant, it dissolves the metal by changing it into a metallic salt that goes into the solution. So there are different etchants are used for different materials, for chemical etching of different materials, like ferric chloride, it is used for aluminum, copper, nickel and their alloys. Ferrous nitrate is used for silver. Hydrogen fluoride, it is used for titanium. HNO3 is used for tool steel, and other etchants are chromic acid, ammonium persulfate, etc. So factors to consider during etchant selection: surface finish you have to consider, material removal rate you have to consider, how much material removal rate is required, depth of penetration, type of workpiece, type of masking, and then damage to the workpiece by etchant, and availability and its cost also matters while selecting the etchant. Thank you.